Good evening, students. Welcome to ISRO Marathon. Is the sound audible to you? Can you hear? Is there any difficulties in hearing? Hope you can hear my voice clearly. It is audible. Okay, sure. Okay, so this will be the last class of this ISRO Marathon because you all know that tomorrow is your exam. Okay, so hope you have all received your whole ticket. So you go through the whole ticket once again before going for the exam. What are the things that you can bring, you cannot bring, how is the negative mark distribution. Some questions will not be having a negative marks, some questions will have negative marks. So just read carefully that instructions before going to exam. Okay, then only you can approach the exams in a correct way. So there are certain questions which are not having a negative mark, that you can understand when read the whole ticket, and again it is also be written in the question paper also. Okay, so I know that it is your last set of preparations and last hours of preparation, so I am not wasting much of time. So let's start the subject. Okay, so today we are going to discuss the subject mechanics of solids. Okay, when the subject rings to your mind, you have to think that the weightage of this subject. Okay, this subject is related to mechanics, which means once you are well aware or well know the facts about mechanics, you can easily score marks in mechanical solids. It is always linked. Then it is related with SA, RCC, steel, like that. Okay, so for all this, the base is always engineering mechanics. There all comes the base. Then you can go with MOS, SA, like that. Okay, so let's see the weightage of the subject over the course of few years of exams. Okay, in 2013, the weightage was 36 marks, which means till 2020 for each question, the weightage was 3 marks. So in 2014, it was 36 marks. In 2014, 21, 15, 12, 17, 21, again 18 marks. 2019, 24 and 2020, it was 27 marks. Okay, which means on an average we can expect questions of about 5 to 8 questions. Okay, so this is a major contribution, right? So let's see what are the questions that has asked in the previous years. Okay, so you have to comment your answers on the chat box. Okay, don't forget to that. Even if the questions are easy or difficult or of higher order, just try to solve that. Even if you are not getting, I will explain that and the related theory also. Okay, so let's start the first question. It is an easy, very easy question. In 2013 it was asked, if the moment of inertia of a section about its axis is if the moment of inertia of a section about its axis is I, section is I, sectional area is A, then its radius of gyration is. If the moment of inertia of a section about its axis is I, okay, the sectional area is A, then what is the radius of gyration? This is a very easy question, right? Your options are R is equal to I by A, R is equal to root of I by A, R is equal to 3 root I by A, R is equal to A by I. Okay, very simple. You all know the answer. Very simple. It is related to mechanics actually. Moment of inertia, center of gravity chapter. So you all can easily answer the question. Yeah, the answer is option B. Okay. Yeah, all are correct. Vinay is correct, Anjali, Shibina, Anupama, Shruti, all are correct. The answer is B. Okay, so there are two moment of inertia. When we think about moment of inertia, there are two types of moment of inertia, which are area moment of inertia and mass moment of inertia. Okay, both are having radius of gyration. Don't forget about that. Okay, so if I is the area moment of inertia, we can write as I is equal to a k square or a r square. Okay, we can write both, where r is your radius of gyration. Okay, r is the radius of gyration, then k is equal to, or r is equal to, we can say that it is root of I by a. Root of I by a. So this is a question. So the answer is option B. It is very easy. When it comes to mass moment of inertia, you can put that accordingly. Okay, let's go to the second question. It is a bit difficult question. It is a bit standard question. It is a higher order question. Okay. A uniform cantilever beam has a span of 2 meters and carries a point load of 6 kilonewton at the free end. Okay. The magnitude of moment to be applied at the free end for zero vertical deflection at that point is, you can neglect the self weight. So it is a higher order question, just asked in 2013 ISRO. Can you give it a try? So you have to know the deflection formulas for both the situations. We have to make the deflection or the vertical deflection at the free end to be 0, and you are having a load at the free end which is of magnitude 6 kilonewton, and then a moment is applied at the free end such that there is no vertical deflection. So what will be the magnitude of that moment? That is the question they have asked, and you are having 4 options which are 5, 10, 11 and 8. Okay, it's a bit tricky question. You have to implement certain formulas, you have to think, and you have to find. Just think what will be the deflection when for a cantilever beam of span 2 meter when this carries a point load. Okay, then there is a deflection for that beam. Then I am applying a moment such that at the free end there is no deflection. Okay, so what will be the moment? That is a question, and you are having options of 5, 10, 11, 8. Always study the equations for deflection and slope for basic load conditions. Okay, you have to by heart that formulas, or you can use any other trick for by hearting that, but you have to study the equations or the formulas of slope and deflection for certain basic load conditions, which means when an UDL comes, when a point load comes, when a moment comes, when the point load is at the center, when the UDL comes, when it is simply support beam, when it is a cantilever beam. So all that situations you have to study the basic formulas. Once you know the basic formula, you can easily solve these questions. A number of questions has been asked about slope and deflection or the formulas regarding slope and deflection. You can see when we discuss questions. Okay, so you have to study the equations for slope and deflection for basic load conditions. Okay, only Binay has said the answer is 8 kilonewton meter. What about others? Others are trying. Okay, let's see what actually is the answer. Okay, the answer is 8 kilonewton meter. What happened to others? Others are doing, or they just forget the formula? Okay, let's see. So before explaining this question, let's see some of the basic load conditions and their formulas. Okay, some of the basic conditions and their formulas, you have to by heart that. Okay, so first one is a cantilever beam. A cantilever beam, a moment m is provided. The direction moment is important. When the direction is changing, you have to put an opposite sign. Okay, so there is a cantilever beam of moment m. What happens to the slope and deflection at the free end or at the point B? Because we all know that the slope and deflection at the fixed end will be 0, right? So theta B is ml divided by EI, and YB is ml square divided by 2E. Okay, then if a similar cantilever of span length L is loaded by a point load at the free end, the corresponding theta B, you have to understand what is theta B. It is at the free end. The theta B is WL square by 2A, and the corresponding deflection is WL cube by 3A. Okay, then if it is an UDL, the formula changes to WL cube by 6EI, where W is the UDL and the unit is Newton per meter. Understand that. The UDL unit is Newton per meter, then the corresponding formula is WL cube by 6EI, and the deflection formula is WL raised to 4 divided by 8EI, where if required you can substitute the capital W also. If you substitute capital W, its magnitude will be equal to small w into L. Okay, remember that. Read the question. What is the data they have given? If the W is your UDL and the unit is Newton per meter, you can substitute the formulas WL cube by 6EI and WL raised to 4 divided by 80. Okay, then let's move on to a simply support beam. A simply support beam with a point load at the center, then the slope at the A and B. Okay, at the free end, slope at A and B are WL square by 16EA, and the maximum deflection. The maximum for this load condition, what will be the maximum deflection? The formula is WL cube divided by 48EA. Okay, Similarly, if an UDL acts, the formula for slope is WL cube divided by 24EI, and the formula for maximum deflection is 5 by 384 WL raised to 4 divided by EI. Here also the value of W is in, or the unit of W is in Newton per meter. Don't forget that. Okay, once it is in Newton, you have to substitute that value. Okay, then again one more. If it is a fixed, okay, if the fixed beam, there is a fixed beam like this, we consider a fixed beam, and there is a point load acting, right, at the center of span L. Already we know that for a simply support, the formula is WL cube by 4080, right. For this situation, the formula changes to Y max is equal to W, no change, L cube, no change, EI, no change. The 48 changes to 192, remember that. The 48 changes to 192, which means 48 into 4 is 192. 48, 96, 192. So 48 into 4 is 192, which means it is almost 1 by 4 or 4 times. Okay, then for a fixed beam, I am taking a fixed beam and giving a UDL of magnitude W Newton per meter. Okay, Newton per meter is the magnitude. So Y max, what is Y max? So for this simply support beam, what is the formula? 5 by 384 WL raised to 4 divided by A. Okay, write that. Let's write that. 5 by 384 WL raised to 4 divided by EA. This is for a simply support beam. If you remove this 5, it will be for the fixed beam. Okay, so what happens? It becomes 1 by 5, right? 1 by 5 or 5 times. Okay, so it is Y max. This is for a fixed. These type of questions has been asked, taking the ratios or regarding what is the value if the length is double, the width is half. Some similar questions has been asked over the course of all the exams. Okay, so you have to study slope and deflection formulas thoroughly. All the questions, or many of the years, one question has been asked from this chapter. Okay, so what happens to our question? Our question is, there is a uniform cantilever beam which means the width and depth are constant for a span 2 meter, and there is a point load 6 kN at the free end. The magnitude of the moment to be applied at the free end for 0 vertical deflection at that point is, okay, fine, let's see. So I am having a cantilever beam. Okay, there is a load that is at the free end, right? Load at the free end, and the length is 2 meter. So if I apply this load, what happens is cantilever beam? This beam will deflect by some value, right? If this point is given as B, this beam will deflect by delta B. What will be the value of delta B? Already we have written, right? What will be the value of delta B? If there is a point load at the free end, what will be the value of delta B? Right? This is WL cube divided by 3A. Okay, so let's substitute that. So the value of delta BV, W L cube divided by 3A. Okay, so I have to give a moment such that there is no net deflection at this point. So I have to give a moment, right? So I am giving a moment in this direction so that this deflection is moving vertical downwards. I have to lift this up, so I am giving a moment in this direction with a value m, so that the deflection is 0, which means the deflection due to point load and the moment must be equal, right? Then only the moment will be, so then only the deflection will be 0. Okay, what happens when the moment is applied at the delta B? It is ml square divided by 2a, right? So if both the values are same, which means the moment deflection and the point load deflection are same, we can say that the net deflection point B is 0. So let us equate that. Delta B1, delta B2. So delta B1 is equal to delta B2. I am equating both. So it is W L cube divided by 3I is equal to AM L square divided by T EI. So we can eliminate EI square 1L. So the moment will be W into 2 divided by 3, right? There is an L also. So it is 2 by 3 into W into L. So what are the values of the span is 2 and the value is 6. Okay, so let's write. So it is 6 into 2 into 2 divided by 3. We can eliminate these two. So 2. So 2 cube is 8. So the answer is 8 kilonewton meter. Okay. So the answer is option B. Most have got the answers right. Okay. So think and find the answer. In mechanics or in MOS, the questions are not easy. We can see all type of questions, which means there are questions which are easy, there are questions which are medium, and there are questions which are higher order, which means it requires some thinking and some calculations. Okay, so some other subjects, it's not direct questions or direct theoretical questions. There has been problems asked, which are most of the questions are from stop and deflection, like higher order questions. Okay, so the answer for this is 8 kilonewton meter. I think 3. Vinaya got the answer, Shivin and Anjali got the answers. I think others have understood what the concept is. Okay, shall we move to the next question? Okay, remember, for the tomorrow exam, there is no calculators. The calculators are not allowed. So you have to do calculations by yourself. Okay, so the calculation part you have to be strong, and as well as the speed is also matters. Okay, so when you come to calculation, you have to put more speed. Okay, let's see the next question. It is an easy question. It's about ISRO 2013. We are going in the order, right? 2013, 14, 15. In that order, we will be discussing about 2020 questions. Okay, so can you find the answer to this question? A bar of 40 mm in diameter and subjected to a tensile force of 40,000 kilogram. Okay, it undergoes an elongation resulting in a decrease in diameter. Consider the properties of the material as E is equal to 2 into 10 raised to 5, and the Poisson's ratio is 0.3. The modulus of rigidity will be like that. Okay, so you can think that this unit is 2 into 10 raised to 5 Newton per mm square. Okay, 2 into 10 raised to 5 Newton per mm square. Okay, maybe it will be steel. Okay, there is a bar having a diameter of 40 mm and the subject to a tensile load of 40,000 kilogram undergoes an elongation resulting in a decrease in diameter. Consider the properties of the material as E is equal to 2 into 10 raised to 5 Newton per mm square and the Poisson's ratio is 0.3. The modulus of rigidity will be. Just give it a try. So you have to think about the formulas that connects the elastic moduli, which are E, K and G. So what are the relations that connects these three? In some questions, there will be certain values that are not necessary for solving the question. Okay, so if the data is given, all the data, you do not have to put it in your calculation. Okay, it is very simple. Just think about the formula, just apply it and find the answer. Okay, Binia has got the answer. Anjali is saying okay. Anubama is also getting A. What about others? Okay, Shivana is also getting A. Okay, let's see what the answer is. Okay. Yeah, all are correct. The answer is A. Okay, so what is the relation or the formulas we have to understand? So we are having 3 elastic modulus. Okay, E, G and K. G can be certain textbook, it is something like N, or C can also be used. Okay, so E, G and K. There are certain formulas that connects these 3 elastic constants or they say elastic moduli. Okay, one equation is A is equal to 2G into 1 plus mu. Another equation is A is equal to 3K into 1 minus 2 mu. And the third equation is E is equal to 9 kg divided by 3k plus g. Okay, these are the 3 formulas you can have to by heart when you prepare for this chapter. Okay, so E is equal to 2g into 1 plus mu, E is equal to 3k into 1 minus 2 mu, E is equal to 9 kg by 3k plus g. So what actually we require? There is a value of E, right? E is given as 2 into 10 raised to 5. Okay, fine. And we are having a Poisson's ratio of 0.3. And we are required to find what is the G value. So which formula we should prefer? These 3 formulas we can easily choose this, right? Because our values and our unknown is given this equation. Okay, let's substitute these values. 2 into 10 raised to 5 is equal to 2G 1 plus 0.3. Just strike off this value, find out the value of G, and the value of G will be option A that you have already said. it is 76923.07 Newton per mm square. Sometimes the question will be like that, the decimal will be there, sometimes it will not be there. Okay, anyway, the correct answer is 76923.07 Newton per mm square. So what is the relevance of this question? This question has the relevance that we do not require these data. For the solving current situation, we do not require these data. And we often get confused that why is this data given? Is there any requirement for this data in the formula? We get confused and we lose time. Okay, these are the tricks they use. Okay, so to manipulate you, they will give unnecessary data that are not required. So you think about that and you will spend some time thinking about that and you lose your time. For this question, we do not require these data currently because we can easily find using the formula E is equal to 2G into 1 plus mu. Okay, so what is E? E is your Young's modulus, right? The ratio of normal stress to strain. G is your shear modulus or modulus of rigidity, that is your ratio of shear stress to shear strain, and K is your bulk modulus. Okay, these three are the elastic constants, and mu is your Poisson's ratio. Okay, I will explain Poisson's ratio in the later question. Okay, let's move on to the next question. Okay, this question is asked two times, in 2013 as well as 2019. Okay, the stress produced in a bar by a suddenly applied load, which means I am applying a load suddenly, is x times one produced by the same load when applied gradually. So I am having two loads of same magnitude, one is applied gradually, one is applied suddenly. What will be the value of x? Okay. Which means how many times the stress will change. The stress produced in a bar by a suddenly applied load is x times the one produced by the same load when applied gradually. Then the value of x is very simple. Once you understand the concept, you can easily solve it. Okay, Anjali has said the answer first, and Bama is giving the answer. Okay. Okay. So Anjali, Anupama, Binny and Shivina are all attempting the questions. Others are not responding. What happened? Okay. So just understand the concept, just give it a try. Okay. Even if you do not know the answer, just try to understand what actually the question means, what are the background of this question, all of things. Okay. Fine. Correct. The answer is option A. So what actually is suddenly applied load and gradually applied load? Which means if you have some load, for example 50 kilonewton, you are applying that load on any bar or any surface. Okay, if I am applying that load gradually like this 10, 20, 30, 40, 50, so I am applying that load gradually. Okay, in that case the stress is simply the load divided by area or the cross section if it is normal stress, which means if I am considering a bar like this, I am applying the load in this direction and this is your cross-sectional area, then it is load divided by your cross-sectional area if the load P is applied gradually on the gradual basis. If this 50 kilonewton load, okay, this is an example is 50 kilonewton. Okay, if this 50 kilonewton load is applied all of a sudden, which means all my force is applied on the surface all of a sudden, in that case your stress value changes to 2 times the force become 2P or it is 2P by A. Remember the concept. Okay, you have to understand that when the load is applied gradually, then only we can say that the stress is P by A. If the similar load is applied all of a sudden or same magnitude, it is said in the question, applied load one produced by when the same load is applied. Okay, which means it becomes 2P by A. What happens to stress? Initially it was P by A, now it is 2P by A, which means it has become twice, or it has doubled, or it has become 2 times. Okay. If any question regarding strain energy is asked, you have to understand that the general equation for strain energy, if the load is applied on the normal stress base, is sigma is not, strain energy is U is equal to sigma square V by 2E, right? So if the stress is applied gradually and suddenly, then the strain energy value will be 4 times. Which means when a load P is applied gradually, you have a strain energy sigma square V by 2E. But the same load is applied suddenly, what happens to your strain energy? It becomes 4 times. Why? Because stress already become twice, right? In the formula it is sigma square, so 2 square is 4. So remember that, okay. When the load is applied suddenly, then similar load is applied gradually, suddenly stress becomes 2 times. And when the load is applied gradually, similar load is applied suddenly, the strain energy becomes 4 times, because in the formula there is sigma square. Don't confuse, okay. So the answer is for this question is option A, twice. Okay, let's move on to the next question. Okay, another question, it is a problem. Try to do two circular mild steel bars A and B of equal lengths having diameters 2 cm and 3 cm respectively. Each is subjected to a tensile of magnitude T. What is the ratio of elongations of bars A by B? Remember, it is A by B is. And you are having options 2 by 3, 5 by 8, 4 by 9, 2 by 5, and it is asked in ISRO 2013. ISRO 2013. One more. Two circular mild steel bars A and B of equal lengths have diameters 2 cm and 3 cm. They are subject to a tensile load of magnitude T. The ratio of elongations of bar A to that of bar B is. A to B is what they have asked. Anyone got the answer? 2 by 3, 5 by 8, 4 by 9, 2 by 5, any? Two circular mild bars A and B, equal length, so length are equal, have diameters 2 cm and 3 cm, is subjected to the load also C. How Aryan has said, sorry, Ayan has said C, Anupama has said C. What about others? Okay, so actually this question is cancelled because it does not have the option what we are getting. Did you get the answers 4 by 9 or did you get the answers 9 by 4? I think you have got the answers 9 by 4. Then you look in the options, then you think that, oh, there is 4 by 9. Let's tick that. Okay, this is the correct procedure. But this question has been cancelled because there is no 9 by 4 in the options. So this question is just cancelled. Okay, all you are saying is correct. 9 by 4 is the correct answer, but the option is 4 by 9. So what we can solve? It is easy to cancel the question because no correct answer is there. Okay, let's see how to approach this question. Okay, so you know the formula for elongation, right? Delta L or anything. It is PL. If P is the force, P it is PL divided by A, right? Okay, PL divided by A. So here the question, it is given us tensile load and the load magnitude is T. So we can write it TL divided by AE. Okay, this is the general formula. So delta L, delta 2 cm, right? So 2 cm, let it be delta 2. That is equal to T is same, L is same. Area will be pi by 4 D2 square E. Okay. So two same materials, which means the E value same. Okay, the material is same, or we can consider that. So E value same. Again E value same. Then same length is there, so the L value same. Then the load is also same, right? So the T value is also same. Which means if T, L, E and same, can we write that delta L is proportional or it is inversely proportional to 1 by D square, since it is a circular section or a cross section, it is proportional to or inversely proportional to 1 by D square. So what happens? So we can write that delta L2 is inversely proportional to 1 by 2 square and delta L3 is, okay, 2 is given us what? 2 is A and 3 is B, right? So let's substitute that. This is A. and this is B. Delta is proportional to 1 by 3 square. So what to do to remove the proportionality? Just divide. Okay, so it is delta LA divided by delta LB, right? So it is 1 by 2 square by 1 by 3 square. So 3 square goes up and 2 square goes down. So it is 3 square divided by 3 square divided by 2 square, which is equal to 9 by 4. Okay, 9 by 4. All you have said is correct. Okay, so the answer is like this. So here what is the issue? The E is same, the T value same, the length remains same, and the cross section is circular, and hence we can say that once we write the formula that PL divided by A, where A is your cross sectional area, it is inverse proportional to D square. We write that situation and we substitute the values of diameter and we divide for eliminating the proportionality sign. Okay, then we will divide and we get the answer 9 by 4. The answer it is given as 4 by 9, so there is no option which says that the answer I am getting is correct, so the question was eliminated. Okay, let's move on to the next question without wasting time. Okay, this is a very good question, higher order top end question, very higher order question. Okay, just think and write. Again, it is related to the vertical deflection. As I already said that you have to study this chapter very well. The formulas of vertical deflection or the formulas of slope for the basic load conditions. Many questions are asked over the 5 or 6 years question papers. Okay, then give it a try. A cantilever beam carries a UDL or uniformly distributed total load W over its whole length and a concentrated upward load W at the free end. Upward load. Okay, the net vertical deflection at the free end is what do we then do? Just draw the figure, just write the formula and find net deflection. The options, don't get confused, the values or the magnitude remains same. There is an upward downward options also, just see which will be the correct answer. Okay, okay, Anvuma has got it first. She is saying it is C. Let's see what are others saying. So think, how are the loads that are provided for the cantilever beam in the directions, and again the uniformly distributed load. I have already said what can be the magnitude of uniformly distributed load. If that becomes capital W, the corresponding equation has to be changed like that. So let's give it a try. What happens? You can use any sign convention, but the direction once it changes, you have to give it one positive and the other negative, because one load is acting downwards and the other load is acting upwards. So the net will be the difference of both deflections. Okay, and again the sign is not given, they are given as upwards and downwards, and the values of option B and C are same, because one is 5 WL cube 24 EI downwards and the other is WL cube, sorry, 5 WL cube 24 EI upwards. So the both the values are same, but the directions are changing. So we have to find what is the correct answer with the magnitude and direction. Okay, only Anupama is getting. What happened to others? Just think about the loading conditions. Okay, simple is that. Then think about the formula. What is the formula? Binia is saying B. So we are getting multiple answers. That's good. Okay, Anupama C, Binia B. Okay, Binia has deleted the message. Okay. So Shivana is saying C. Okay. Okay, let's see actually what is the formula. The answer is option C. Okay, shall we see what actual the question means? Okay. So, there is a cantilever beam, fine. There is a uniformly distributed total load, remember that, okay? It is a uniformly distributed total load of W over its whole length, okay, fine. There is a concentrated upward load, so there is a constant upward load at its free end. Then the net vertical deflection will be, that is a question. So, let us draw what actually is the figure. Okay, so there is a cantilever beam. So, I am having a cantilever beam. Okay, there is a UDL acting in this cantilever beam. So, once the directions are not given, they normally act in vertical downward direction. So, there is a UDL. So, this UDL is given as capital W, which means that capital W includes small w into length. Okay, remember that. If the UDL unit is Newton per meter, you can substitute small w. Once it is given as total load, it is given as capital W. And the capital W will be, how to convert a UDL into a point load? You have to multiply that, the value of UDL into that length, right? So, it is W into L. Then, there is another load, right, at the free end in a vertically upward direction. So, it is W, right. So, what happened due to this UDL? Due to this UDL, this deflects in the downward direction. Yeah, I will use another color. Okay. Due to this UDL, there is a deflection in the downward direction. Okay. And what happened? This point load, there will be a deflection not in the downward direction, there will be a deflection in the upward direction, like that. It's not whether it goes upwards, it's like that, it's not going downwards, it is lifting up. Okay. So, our net vertical deflection will be what? Difference, right? Net vertical deflection will be the difference. So, due to this UDL, let it be UDL, let it be delta 1, and let due to point load, let it be delta 2. Okay, fine, no issues. Then, let the downward deflection taken as positive. Okay, I am just considering, you can consider any sign, no issues. I am considering the downward deflection as positive and the upward deflection as negative. Upward is negative. Okay, fine. Because in the question they have also asked about the direction also. Okay, so what is the net vertical deflection? Okay, so due to UDL on a cantilever beam, what is our formula? Do you remember? Due to UDL, the deflection is WL raised to 4 divided by 8A, where W is your UDL in Newton per meter. Once it is given as total load, this formula will get modified like this, because 1 W into L is taken as capital W. So, we lose one length, right? So, it is written as W L cube divided by 8 EI, where W is your total load of that UDL. Okay. So, W L cube divided with 8A. Then, what happened to the point load? It is W L cube divided by 3A, right? So, one is 8 and other is 3. Let us move to the question. So, it is W L cube divided by 8A. So, it is vertically acting downward. So, it will be positive. And due to this point load, it is upward. So, it is minus W L cube divided by 3A, right. Let us take the common factor W L cube divided by EI. It is 1 by 8 minus 1 by 3. Okay, you can give us LCM again. This value remains same, W L cube divided by EI. You can take the LCM as 24. 24, 8 goes to 3 and 3 goes as 8. 3 minus 8. So, what will be the answer? Minus W L cube divided by, sorry, minus 5 W L cube divided by 24A. Why this minus? Because I assume that the downward deflection is positive and the upward deflection is negative. I got the answer as negative, which means the net deflection will be where? Where? It will be in the upward direction. In the question, if you see, even if you are getting the value right, you may not get the correct answer, because in the option they are given same magnitude, option B and C, one the direction is downwards and the other is upwards. In the question, when I find that the negative answers I am getting, so someone other can write this as downward direction as negative and the upward direction as positive, then he may get the positive answer. Okay, whatever it is, The sign convention I want considered, once I am getting the negative answer, the negative is the upward direction. So the answer for this question is option C, not B. I think you are understanding this. Okay, so you consider one sign, you put that sign value, you get the answer. So according to that sign, you can find whether it is upwards or downwards. There is no sign convention that the downwards should always be positive. It is simply like that, once you put the downward direction as positive, then the upward should be negative, or the downward should be negative, then the upward should be positive. It is not that always the downward should be positive, not like that. Okay, you can think of any sign convention, but you have to implement the directions accordingly. Okay, so the answer for this question is C. Anupama got it right, Vinny has removed the message, Shibina has got it right, and Anjali has got it right. Okay, others, I hope you have understood the answer or understood the concept. Okay, so deflection, stop, very, very important. Shall we move to the next question? Okay. It is a very easy question. Again, 2013 is the question. The maximum shear stress in a rectangular beam is dash times that of the average shear stress. A theory question. All the preparing students will know the answer, right? Because you all study these answers. What happens to a rectangular section? What happens to a circular section? What is the case of a triangular section? All those things. What is the relation between average and maximum? Okay. All of you are correct. 1.5. C, 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 and C. Okay. So maximum shear stress in the rectangular beam is dash times that of the average shear stress. The answer is C. Okay. So what is the consideration in this? Or what are the values I need to study about this? So once you consider any cross section, first of all understand along the cross section, the shear stress variation is parabolic. You have to understand like that. Okay. Your shear stress variation will always be parabolic. So the maximum value will be at some point, and the minimum value or the zero value will be along at the edges or the top and bottom fiber. So for any type of loading, if the loading is if the cross section is symmetry, we can easily write that the variation shape will be parabolic. The variation shape will always be parabolic. Okay, this is always variation. So it's a symmetric figure. So this is your neutral axis. For a rectangle, this is the maximum shear stress, and for a rectangle, tau max is equal to 1.5 to average. Okay, what happens to a circle cross section? For a circle, tau max is equal to 1.33 to average. Okay, both are symmetrical in cross section, so the neutral axis will be the place where we get the maximum shear stress. What happens in case of triangle? Triangle is not a symmetric section, right? Once you saw the figure, it is not a symmetric section. So here we are having two values. The shear stress at the mid height is 1.5 to average, and the shear stress at the neutral axis is 1.33 to average. Please study this, okay? Because many of you get confused with these values. So your circle and your rectangle are both symmetric sections. So your neutral axis will be the place where you are having the maximum shear stress, or that neutral axis will be your mid height. Okay, for rectangle it will be 1.5, for circle it will be 1.3. When it comes to the case of a triangle, it is not a symmetric section. So we are having two different values, one at the neutral axis and one at the mid height, which are in a way these two values repetition. Okay, so once you have 1.5 value and 1.3 value, what will be the maximum value? That is at the neutral, so that is at the mid height, and that mid height value is 1.5 to average, and the neutral axis value is 1.33 to average. Okay, many of you get confused with these two, because in your option they will give both two options. So for a triangle, at the mid height it is 1.5, and at the neutral axis it is 1.33. Okay, so the answer for this question is option C. Okay, let's move on to the next question. Again, this is also a very good question. You have to think and answer. It is a theory question, but you have to think what does the question means, what is uniform strength means, then only you can solve this question. If the depth is kept constant for a beam, if the depth is kept constant for a beam of uniform cross section, then its width will vary proportional to. If the depth is kept constant for a beam of uniform strength, then its width will vary proportional to, where m is the moment, which means what is the relation between the width and moment m for a beam of constant or uniform strength. So you have to understand what actually is a beam of uniform strength. What actually is a beam of uniform strength. Once you understand what actually is a beam of uniform strength, then think how it can be achieved. Okay. Once you get that idea, you can easily solve this. So if you are not able to know what actually a beam of uniform strength means, then it is difficult for us to solve this question, because beam of uniform strength, many of get confused. Uniform strength is constant, like that. It's not like that. Sum is constant, not strength. Okay. So the answer for this question is okay, option A. Okay. What actually is a beam of uniform strength? Uniform strength means these beams have constant bending stress. Remember, what does actually a beam of uniform strength means? This beam has constant bending stress. Okay, your bending stress is constant. Then think about the bending equation. You know that the bending equation is m by I is equal to f by y is equal to e by r. Okay, this is your bending equation, right? So let's take the first two part. This m by I is equal to f by y. Okay, the depth is kept constant, width. So the related to depth and width. So you can assume that the cross section is rectangular, because many of the beams or all of the beams we see in our practical cases are all rectangle, right, or square. Okay, so let's take that the cross section is rectangle. So m by I is equal to f by y. So just changing m is equal to f into I by y, and your I by y is known as the ratio of I by y. What will you say the ratio of I by y? When we study the bending stress, what actually means the ratio of I divided by y? I by y. Okay, Z. What is Z, Ninya? It is your section modulus. You study a number of section modulus when you prepare for competitive exams. You study section modulus, you study plastic section modulus, you study polar section modulus. Don't get confused with these section modulus values. Okay, these are all that you study in different concepts. Once you study about the bending, you use section modulus. When you study about torsion equation, you use polar section modulus. When it is related to plastic analysis of steel, you use plastic section modulus. Okay, so just remember these three differences. Okay, so it is section modulus or okay elastic section modulus. So it is f into I divided by y. So we can say that m is equal to f by z. Okay, fine. Your rectangle is there, so rectangle z value is bd square by 6. So m is equal to f divided by bd square by 6. Okay, fine. So you are getting like that. So m is equal to f divided by bd square by 6. Okay. So m is equal to f divided by or 6f divided by bd square. In the question they have said that the bending stress is constant because the beam of uniform strength, right? Already d is taken as a constant, then d is also a constant. So what is the relation between b and m? It is proportional, right? The relation is proportional. There is no root or there is no anything like that, right? Let's take the question once more. That is bd square by 6. You write bd square by 6. It will vary proportional to, which means what is the power of m? It is m or root m or m square or m cube. That is the question they are asking. And when we write this, that we can understand that m is equal to 6f by bd square, which means that the powers of both are 1, which means the power of m is also 1. So the answer is option A. Okay, your answer is option A. Correct. So let's move on to the next question. It is 2014, so we have reached the end of 2013 and we are moving to 2014. So these questions are 2014 year questions. So just 1 minute. Sorry, it's not divide, right? That is a mistake I got. That's why I get confused. So it is m is equal to f into I by y, right? M is equal to f into I by y. So it is I by y is z. We can write it not like this. So you get m f into I by y, right? So I by y is our z value. So we can write m is equal to f into z, and m is equal to f into b d square divided by 6, not denominator, sorry, it is in the numerator itself. So again, f is a constant, your d is a constant, so we can say that our m is proportional to b. Okay, so it is m into I by y, where I by y is your section modulus or z, so we can say that m is equal to f into z, not divide. Okay, sorry. So it is m into z, then m is equal to f into b d square by 6. Provided that f and d are constant, we can say that our m is proportional to b, which means both the powers are 1. So the answer is option A. Okay. Now do this question. Okay. So a bar of copper and steel form a composite system. Okay, which is heated to a temperature of 40 degrees Celsius. The stress in the bar is. A bar of copper and steel form a composite system, okay, which is heated to a temperature of 40 degree Celsius. The stress in the bar is, have to clarification, the stress in the steel bar is, okay, the stress in the steel bar is the question, okay, not about the bar, stress in the steel bar. So a bar of copper and steel form a composite system which is heated to a temperature of 40 degrees Celsius. What is the stress in the steel bar? Not in the bar, stress in the steel bar. It is tensile, compressive, shear or 0. So you are having a composite bar. So you have to understand that what does a composite bar means, first of all. Then it is heated to a temperature, it is heated up, which means you are increasing the temperature from some particular value to 40 degrees Celsius, or the temperature itself increased to 40 degrees, whatever it is. So you are heating, which means you are increasing the temperature to 40 degrees Celsius. Then the steel bar, what actually will be the nature of the stress? That is a question you are asking. Okay. Okay. So it's A, B, A. Okay, let's see the actual answer is. It is option A, tensile. Okay, so let's see what actually it means. So it is not the bar, it is a steel bar. Okay, steel bar. So what actually is a composite member? You have to understand first of all like that. A composite member, what actually it means. Okay, a composite member is like this. You are having more than one bars. Okay, so let's see. This is my steel, and this is my, I think it is copper, right? So copper. So composite member means all the things will be same. So C is the steel and C is the copper and S is the steel. And if you cut a cross section like this, you will be able to see more than one materials. That is the meaning of a composite bar. This is actually a composite bar. So what is it different, or how it is different from a compound bar? The difference is like that, if the same material, if I place like this, okay, so again one is steel, other is copper, this actually means a compound. So what actually is the difference? The difference is that if you cut a cross section here or anywhere, you will be able to see only one material. Even though it contains more than one material, if you cut a cross section, you will be able to see only one material. This is the meaning of a compound bar. This is a composite bar. Composite means if there are more than one materials, and if you cut a cross section, you will be able to see how many number of materials? all are you will be able to see. Okay, even though it contains more than one material, they act as a single member. When it is loaded or when it is heated up or heated down, they act as a single member. Okay. Then when we compare steel and copper, the coefficient of thermal expansion or the coefficient of linear expansion of steel is less than that of the copper alpha value. Remember that. Okay. When we compare a composite member, one is having steel and other is copper, the coefficient of thermal expansion or the coefficient of linear expansion of steel is less than that of copper. Which one or whichever is the material which is having a larger coefficient value or the coefficient of thermal expansion of linear expansion, it expands more when heated and it contracts more when heated down. Remember that. Whenever you are heating up a material, the one which is having a larger coefficient of thermal expansion expands more compared to that of the other one. Okay. Then remember, if these two materials are considered, if simply these two materials are considered individually, we can say that this expands more, right? If I am considering steel as one material and copper as another material and they are considering and allowed to expand individually, copper will expand more because it has larger value and steel will expand less because it is having smaller value. If these two are allowed to expand individually, but this is actually not the case. These two are acting as a compound member or a composite member, right? So if these two are acting as a composite member, they expand on the equally or they expand equally. So what will be the expansion if I am considering this as a compound member? Composite member. So this actually is that of steel and this actually is that of the copper. So if I am considering as a compound metal, if I am considering it as a composite material, they expand in between, or in between does not mean right the middle. Okay, it is between this and this. Okay, so if I am considering steel and copper as two separate individual members, copper expands more and steel expands less since the coefficient of linear expansion of copper is greater than that of steel. But if I am considering this as a composite material, these will act as a single unit and they expand in between these two expansions or these two values. So what happens to steel? Actually, it can only expand this, but since it is fused or it is in composite with copper, it expanded more than this, right? If it is expanding, what happens to steel? It is in tension, right? So what happens to copper? If it is allowed to expand individually, it can expand this, but it only expand this much because it is fused or in composite with the steel, which means what happens to this? It has been compressed or compression. So understand, when a composite material or a composite material is heated up, when a material is heated up, the one which is having lesser alpha value will be in tension and the one will be having larger alpha value or the higher alpha value will be in compression in case they are heated up. Okay, if a composite material is heated up, the material which is having lower coefficient of linear expansion will be in tension and which is having higher linear expansion will be in compression. Similar will be the case of steel and aluminum. If you consider steel and aluminum, similar will be the case. Steel will be in tension and aluminum will be in compression because the coefficient of thermal expansion or the linear expansion of aluminum is greater than that of the steel. So steel will be in tension, aluminum will be in compression. Okay. So whenever steel comes along with the copper or aluminum as a composite member, steel will always be in tension. In this question, it is asked that what happens to the steel bar. So if it is steel bar, it is having lesser coefficient of linear expansion, so it will be in expansion and it is in tensile. Okay, expand means it is in tension. Okay, hope this is clear. Understand the concept of composite member. Okay, so composite member means when you cut the cross section, you will be able to see both the materials. Okay, fine. So let's move on to the next question. Okay. A similarly supported beam of span L carries a total load W which is uniformly distributed. Again, it is a total load, remember. The maximum bending moment M is. the maximum bending moment M is. And you are having option WL by 2, WL by 4, WL by 12, WL by 8. Again, here also there is a total load W, or there is a UDL which is having a total load W. What is the maximum bending moment? What is the maximum bending moment? What is the maximum bending moment? It's very easy, very easy. Okay. Yes, it's a D. Okay. Yeah, it is D. So what happens? You are having a simple support beam, right? It is supported with acting on a UDL. If this magnitude is W, you all know what happens to the maximum bending moment value, right? Bm max. You all have by heard that. It is WL square by 8, right? WL square divided by 8. So it is given as total load W. So what is total load? So I already said the small w into 1L takes the total load. So we can write that it is WL by 8. So the answer is option D. It is WL by 8. Okay, very simple. Okay. Then let's move on to the next question. Again, this question is related to deflection. 2015 ISRO exam. Read the question, give the answer. Options may get confusing, but just think and answer. If the depth of the simply supported beam carrying an isolated load at its center is doubled, the deflection of the beam at the center will be changed by a factor. So you have to remember the equation of deflection for this corresponding loading condition. They are changing the depth. So what actually happens to the deflection? Okay. So Anjali is saying D. Aisha is saying D. Anubhav has said D. I think D is also the answer for the previous question, right? Yeah, maybe some are saying the answer to that question. Okay, what is the answer? The answer is D. Okay, let's see what actually means. So you are having a simply supported beam carrying an isolated load at the center. Isolated load means point load. Okay, so you are having a simply supported beam. There is a point load at the center. At the magnitude will be W and the L be the length, and simply supported beam center doubled. So the depth is doubled. Fine. So only the depth has changed, which means it has to be understood or should be thought by like that only the depth is changing, remaining all the parameters or all the remaining parameters are constant. Only the depth is changing. Okay. Then what will be the equation? What will be the equation for delta or the delta max? Delta max equation is, if W is the load, WL cube divided by 48 EI, right? EI. So where actually D comes? Length is there, E is there, the D comes in the I, where I is your moment of inertia. Okay, so for a rectangle, the moment of inertia you already know, it is B D cube by 12, right? The moment of inertia for a rectangle is B D cube by 12. So let's substitute this. So your delta max is equal to W L cube divided by 48 into E into I is B D cube divided by 12. So I have understand one thing, that my delta is inversely proportional to 1 by D cube, is inversely proportional to 1 by D cube. Okay, so if I am saying this as delta 1, it is inversely proportional to 1 by d1 cube. What happens to delta 2? Again, it is inverse proportional to 1 by d2 cube, right? One is d1 and other is d2 cube. Then think, if the depth is doubled, so inversely proportional to means that if you increase the value, your deflection will decrease. That is the logic, right? If you are increasing some value, the corresponding other value will be decrease. That is the meaning of inversely proportional. Okay, so I am increasing the depth twice. Okay, so d becomes 2d. So what happens? 2 cube becomes what? 8, right? 2 cube becomes 8. So actually what is happening to deflection? Is it increasing or decreasing? The question is asked like that. The deflection of the beam at the center will be changed by a factor. If the answer is 8, which means your deflection is increasing 8 times. Is that the way? No, na? Because it is in the denominator. So denominator means once your depth is increasing, the corresponding deflection is decreasing. So if your depth is increased 2 times, 2 cube is 8 and it is changing by a factor, not 8, it is 1 by 8. Then only the depth will decrease, not it is increasing. This is the wrong answer. The answer is option D, 1 by 8. Okay, just see your answer. Okay, it is you have said C. So this is the explanation for that. If the answer is C, it means that once your depth is increasing, your corresponding deflection is also increasing. It is not actually the case, because we understand that the deflection is inversely proportional to the depth. So once your depth increase, naturally your deflection decreases. If the answer is 8 times, it means that once your deflection is, so once your depth is increased, your corresponding deflection is also increasing. So it is not correct. So when the depth is doubled, 2 cube is 8 and your deflection is reducing, which means it will change by a factor, not 8, it is 1 by 8. When we apply the formula and when we take the ratios, we may get confused with the answer. Okay, so they will put options like that, 8 and 1 by 8, to confuse you. Okay, so think that. If you think like this, there will not be any issue, because once the depth is increased, the corresponding deflection is decreasing. My depth is increasing 2 times, 2 cube is 8, so my deflection is decreasing by a factor 1 by 8. What is changing by a factor? 1 by 8. Hope it is clear. Okay, so let's move on to the next question. Yes, this question we have already discussed. What is the things? The maximum shear stress to average shear stress ratio. The beam is circular in cross section. Quickly answer the question. Very quick. Just read question, options, answer. Don't get confused with the options, because one is the other. A and B are just reciprocal. C and D are just reciprocal. Don't get the answer wrong, because once you get the answer wrong, it is difficult. Okay, just read, give the answer. Yeah, okay, fine. All are saying it's D and the answer is D. Correct. Okay, so we have said that for a circular section, tau max is equal to 1.33 tau average, right? We have already explained that. So what is 1.33? Tau max is equal to 1.33 means 4 by 3 tau average. They have a ratio of maximum to average, right? So tau max by tau average is equal to 4 by 3. The answer is option D. Easy 1 mark or easy 3 marks. Okay, let's move on to the next question. Very simple question. 2017, we have reached 2017. What actually is modulus of rigidity? You already know. Just read the question, give the answer, and let's move to the next question. So there are easy questions, there are moderate questions, and there are higher order questions. Okay. D, 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 D. Yeah, everybody knows, right? What actually is modulus of rigidity? Modulus of rigidity is actually your G, or shear stress modulus. Okay, is your G, or it is your N, or it is your C. It can be anything like that. Okay, it is simply the ratio of shear stress to shear strain. Very easy, right? The answer is option D. Nobody will get it wrong. It is the ratio of shear stress to shear strain. What actually is Young's modulus? Young's modulus is the ratio of direct stress to strain. And what actually is your bulk modulus? It is also the ratio of direct stress to volumetric strain. Okay. So these three definitions you have to understand, and these three relations connecting E, G and K we have already discussed in the previous questions. You have to understand that questions can ask with the problems. Okay, let's move on to the next question. Okay, so this is actually an elongation question. Just read the question and just write the formula. You have to write the formula, you get the answer, but the answer is very simple. You can get in 10 seconds once you understand the question. Okay. Two bars of different materials and same size are subjected to same tensile force. Okay. If the bars are having unit elongation in the ratio 3:5, then the ratio of the modulus of elasticity of the materials will be. So the materials are different, but the size and force are same. So just write that simple equation. Just apply it, solve it, answer very easy. You can easily say that. Okay. C. Okay, all are correct. The answer is C. This is regarding the formula for elongation, right? So write the formula for elongation. Anything delta L. Delta L is PL divided by A, right? So they have said that the loading is constant. So this is a constant. Okay. Then what they have said? The length is also constant. The A is also constant, which means my change in length is inversely proportional to E. That is a simple case. Okay, fine. What is the notation? They have given A or B or something like that? No, simply they have given two bars of same material, same size. Same size means the length are same and the cross section are same. Same tensile force. Unit elongation is there. So let's write. So delta L is inversely proportional to E, which means that delta L1 is inversely proportional to 1 by E1. Okay, and delta L2 is again inversely proportional to 1 by E2. That is also okay. Let's divide both. Actually, once you write this, you will simply get the answer, because when we divide this, it is delta L1 by delta L2 is equal to E2 by E1. There lies the answer. Delta L by delta L2 is E2 by E1. So they have given the ratio as delta L1 by delta L2 as 3:5, right? So the ratio of these bars are 3:5. What will be the ratio of these materials? So we can say that if delta L1 by delta L2 is equal to E2 by E1, then E2 by E1 is 3/5, right? They have asked the ratios, which means the proportion or the respectively means it should be E1 by E2, because they have said that 1 by 2. So what happens E1 by E2? It is again 5/3, which means it's the reciprocal value or the reverse value. So the answer is option C. If they have asked what is the ratio of E2 by E1, we can say that it is option B. So just read the question correspondingly for correct finding the answer. We may get confused or they will make us confused. Okay, so the answer is 2:5, no issue. 3:5, 5:3, we may get confused. Okay, so delta L1 by delta L2 is E2 by E1 and E2 by E1 is 3:5 or 3/5. They have asked E1 by E2. So it is 5:3 and the answer is option C. Okay, let's move on to the next question. Very simple question. ISRO 2017, you have asked about the modulus of rigidity. Once you know the formula, you can apply and find the answer. Just give it a try. Try to solve these questions without using calculator, okay? Because calculator is not allowed for tomorrow's exam. So you have to increase your calculation speed. That only can be done when you do more questions like this. Speed also matters for these competitive exams. Okay, Aisha, you said C. Shivana, you said 60. Anjali is saying C. 60 means C. What is happening to others? Vinaya is saying C. What happens to Anupama? Normally, she gives the answer. Okay, let's see the answer. The answer is option C. There is nothing in this question. Simply just give the formula. E is equal to 2G into 1 plus mu. So you are having an E value of 150. That is equal to 2G 1 plus 0.25, which means 1.25. You can write actually 1.25 into a fraction, like 5 by 4 is 1.25. Okay. If you require, you can substitute that like 150 is equal to 2G into 5 by 4, because we are having another multiple of 5 here. So you can easily strike off these values, strike off this value, strike off these values. So this 2, so it is G is 300 divided by 5, right? 150 into 2 by 5. 300 divided by 5, it is 60, right? So the answer is option C, 60 GPA. Okay. Okay, fine. Let's move on to the next question. Next question is a bit tricky. Try to solve without using calculator by any of your method. Okay. This question is about theory of principal planes. A body is subject to a direct tensile stress of 300 MPa in one plane accompanied by a simple shear stress of 200 MPa. What is the maximum normal stress, which means it is related to principal stress situation or the chapter. So you have to remember the formula and try to solve without using calculator. If you have calculator, you can easily solve that once you know the formula. Okay, just try without using calculator. So your options are minus 100 MPa, MPa means megapascal, 250 MPa, 300 MPa and 400 MPa. Similar question asked also in 2019 or 20. We will also do that question also. Just give a try. Principal stress formula that you have to study. Okay, maximum principal stress, minimum principal stress, or the major principal stress, minor principal stress formula, and the shear stress. Three formulas that you have to study. Once you understand or study the concept or you know the concept, it is easy for you. Anybody getting an answer? Shivra is saying they hope she has not used the calculator. If you use the calculator, you get the answer very easily once you know the formula. Okay, try to solve without using calculator. Okay. Okay, I shall also say B. Okay, so multiple options is there. Okay, let's see. So you have to know the formula. The answer is option D, 400 MPa. So you have to understand the formula. So this is related to principal stress. So what is your maximum or major or minimum, whatever it is, maximum or minimum, they will be asking. The formula is if x and y or sigma x and y are your tensile stresses. If sigma x and y are your tensile stresses, then the equation for sigma max is sigma x plus sigma y by 2 plus or minus root of sigma x minus sigma y by 2 the whole square plus tau xy square. Okay, there is a root also, but don't get confused. You will be able to solve this without using calculator, I will say. Okay, so this is the equation for finding the maximum or minimum stress, where sigma x and sigma y are tensile, both should be tensile. If anyone get compressive, an additional negative sign should be put. Okay, so it's sigma x plus sigma y by 2 plus or minus sigma x minus sigma y by 2 the whole square plus tau xy square the root. Okay, plus gives the major or the maximum value, minus gives the minimum value, and in this case what will be your shear stress is equal to root of sigma x minus sigma y by 2, or your maximum shear stress tau max is equal to sigma x minus sigma y by 2 the whole square plus tau xy square. Remember these two formulas, it will be useful to you. They may ask, or in the previous years they have asked about maximum, or they can ask tomorrow about the minimum or the maximum shear stress. So if you study this formula, your maximum shear stress is already in this formula. There is no need to study an extra formula. So if sigma x and sigma y are the two tensile stresses acting, then the equation for maximum stress is sigma x plus sigma y by 2 plus or minus root of sigma x minus sigma y by 2 the whole square plus tau xy square. And in this, that root will give you the maximum shear stress, plus will give you the maximum stress, and minus will give you the minimum stress. In both the equations, your sigma value, sigma x and sigma y should be tensile in nature. Okay, here what actually is the question? They were asked about the maximum value, right? So we have to put only, and there is only one stress in one direction that is given, which means let's say sigma x, or let's say sigma x. What actually sigma x is given? It is 300, right? Yeah, sigma x is 300. Okay, so your sigma x is 300 MPa, let it be like that. There is no sigma y, they have not given, so it will be 0. Then the tau xy is again what actually it is 200 MPa, right? So let it is the formula. So it is the sigma max, the maximum normal stress equation is, or the maximum tensile stress is sigma x, there is no y, so sigma x by 2 plus we need maximum root of sigma x by 2 the whole square plus tau xy square. That's so. So sigma x, it is 300. So 300 by 2 is 150, right? Plus root of 150 square plus 200 square. For this, we require calculator? No. Just think how we can solve this without using calculator. Let's take 50 as common. In both this value, we can say 50 as common. Okay. So 150 plus root of, we can say 50 into 3 square plus 50 into 4 square. We can write this like, okay. So there is common 50, we can take that 50 out, there is a root, so out means 50. So it is 150 plus 50. There is 50 square, I am taking that out, root, that is 50. Root of 3 square plus 4 square. You all know what is the root of 3 square plus 4 square, right? 3 square plus 4 square will give me 5 square root is 5, right? So we can say that the sigma max is equal to 150 plus 50 into 5, right? So what happens 50 into 5? It is 250, 150. The answer is 400 MPa. This is the way you can easily solve the question. You do not require calculator. Even though there is a root, we do not require any calculator. Simply solve by using your logic. Okay, it is clear the way I have done the problem and the formula. So you have to study the formula. This one formula is enough. In this one formula, all the three formulas are there. If they ask max, you have to do plus. If they ask minimum, you have to do minus. If they ask for shear stress, simply write the formula within the root. Okay, so the answer for this question is option D, 400 MPa. Clear? Okay, so let's move on to the next question. The time is going. Okay, another question. Again deflection. How many questions we have done right now about deflection? 3, 4. Okay, so study deflection. Sorry, I have said the answer also. Okay, just find the answer. There is simply support beam A which carries a point load at its midspan, or midspan means, don't get confused, it is a midpoint, right? Which means midpoint. Okay. Another identical beam, which means identical means all the values remain same. The cross section, E value all remain same. Carries the same load but uniformly distributed over the entire span. Okay. The ratio of maximum deflection of beam A to B. Read the question, it is A to B. Accordingly find the answer, because in the options there are reciprocals also. 8 by 5 is there, 5 by 8 is there, 3 by 5 is there, 5 by 3 is there. Okay, so read the question accordingly and find the solution. It is A by B, reflection ratios. Just write the formula, take the ratios, find the answer. What they have asked also, think. Actually, you have to say an answer. Same load is acting as an UDL, so you can think like that. Okay, let's see what the actual answer is. The answer is option A. Okay, let's see what actually the question means. So I am having a simply supported beam. This is beam A. There is a point load at the center W. Then delta A is, what is W L cube divided by 48 A, right? Then there is another simply supported beam, same situation. There is a UDL, right? When an UDL comes, they have same loading, which means they have mean that the value is also W. Okay, so what happens to delta? This is B, right? So what happens to delta B? W L raised to 4 divided by EI into 5 by 384, right? This is actually we are saying. So when the total load comes, what we can say, we have already said like that, delta V is W, one length goes, so WL cube divided by EI into 5 by 384. We need the value of delta A divided by delta B, right? So delta A divided by delta B. All the alphabet gets cut off, W get cut, L cube cut, EI all get, only we are getting the numbers. Okay, so it is 1 by 48 divided by 5 by 384. What happens? This 384 goes up, so 384 divided by 5 into 48. You have to divide 8, 48, 8. So the answer is 8 divided by 5. The answer is 8 divided by 5. Right? So the answer is 8 divided by 5. So it is option A. All have got it correct. Okay. So remember, when total load comes, you have to change the equation into that way. Then only we get an answer. Okay. Shall we go to the next question? Okay. This is another theory question. 2018 we have reached 2018. We have 2 more years. So let's speed up. Okay, answer is option D. Okay, so the question is, what actually a shear force in a simply supported beam means? You have to understand what actually shear force is. It is the algebraic sum of the vertical force or the transverse forces either to the left or right of a section. You are considering a section to a left or right. You have to take the algebraic sum. What is the meaning of algebraic sum? Algebraic sum means you have to consider the sign also, which means if the force is acting downwards, you have taken it as positive, then the upward force will be negative. It is not the same way. You can take the downward force as negative, then the upward force will be positive, which means you have to consider the sign also. So shear force is the algebraic sum of forces either to the left or right of a section. So algebraic sum is there, even though sum of transverse forces, transverse force means it is just like that. You are taking a beam like this is the length direction, right? Then the force is acting in this way, this in this way. So this is the transverse direction. This is the longitudinal direction. The forces are acting in the transverse direction or the in perpendicular direction. That is the meaning of transverse direction. Okay. So it is sum of transverse forces is partially correct, only partially correct. There is a better answer, option D, algebraic sum. So when sum and algebraic sum comes, the answer must be algebraic sum, because algebraic sum we consider the sign also. Sum we do not consider the sign. So the answer is option D. Similarly is the case of bending moment. What actually is the bending moment? It is the algebraic sum of forces or the algebraic sum of the moments due to the transverse force either to the left or right of the section. So in case of moment, we consider either clockwise moment as positive, anti-clockwise moment as negative, or the reciprocal, anti-clockwise as positive, clockwise as negative, or maybe you have studied Hawking sag. You can use any sign convention, but you have to consider sign also. So bending moment is algebraic sum of moments due to the transverse forces either to the left or right of the section, and shear force is algebraic sum of the vertical force of the transverse forces either to the left or right of the section. So the answer for this question is option D. Okay, let's move to the next question. Okay, again a theory question. You can easily able to answer that. When a body is elastically stretched, the Poisson's ratio, not ration, it is ratio. The Poisson's ratio is, so you are stretching a material, what will be the value of your Poisson's ratio? It is greater than 1 or less than 1 or equal to 1 or none of these. Is it greater than 1, less than 1 or equal to 1 or none of these? So when a body is elastically stretched, what actually is your Poisson's ratio or the value of Poisson's ratio? You will remember the values of Poisson's ratio. It will be in between some range, or you know the range. Just think about the range and give the answer. It is not that much difficult. Greater or less, equal or none of these. Only Binia is getting the answer. What happened to others? You know the range of Poisson's ratio, right? So just think that value. Okay, only Binia and Shibina is saying the answer. It is not that much difficult. You can say the answer. It is B, less than 1. Okay, so what actually is the Poisson's ratio? You can denote it by mu or it can denote it by 1 by m. It is a ratio of lateral strain by longitudinal strain. I hope you all know that lateral strain by longitudinal strain, there is a negative sign also we can, if required, we can put, because lateral strain means if I am taking a bar and if I am applying a load like this, so the dimension that is acting along the force is the longitudinal direction, and that is perpendicular means the lateral direction. This means if I am applying a force in this direction, which is tensile, there is a tendency that this length will increase. This is the longitudinal direction. There is also a tendency that if this is the height, this is the longitudinal direction, sorry, this is the lateral direction, there is a possibility that this can get decrease. There is a decrease, of course. So, this decrease can be indicated by the negative sign, but for the general values, we do not consider the negative sign. We just simply take the value. Okay. So, it is a ratio of lateral strain to longitudinal strain. What is lateral or what is longitudinal? If I am applying a force, the dimension along the direction of that force is always longitudinal, and the perpendicular one is always the lateral. What happens to the longitudinal dimension? The thing that happens to the lateral dimension will be opposite. If the longitudinal value is increasing, the lateral value will be decreasing, or if the longitudinal value is decreasing, the lateral value will be increasing, which means both are opposite in nature. Okay. So, the ratio of these values will be mu, and the value of mu for materials or bodies. Remember, the value of mu for materials or bodies varies from 0 to 0.5. Okay. Materials or bodies will vary from 0 to 0.5, but the theoretical value of mu is -1 to 0.5. Okay. Don't get confused with these two values. If they are asking for any engineering material or any physical body, the value of mu will be 0 to 0.5. When it is asking theoretically or simply, if you do not see this in your option, you can go for this -1 to 0.5. Remember, if there is a statement like this, body or material, the answer must be 0 to 0.5. If there is nothing like that, and if you are not getting this value, you can go for this value is -1 to 0.5. Okay. So, here the answer is less than 1, greater than 1, equal to 1, and the answer is option B, because 0.5 value is less than 1. Okay. So, this is the answer of question. Okay. Let us move on to the next question. Okay. Again, a theory question, what you already know the answer actually, I think. What is principal plane, or it is related to again principal plane, principal stress. Yeah, you all know the answer, right? Along the principal plane subjected to maximum principal stress, what is your shear stress? It is 0, or it must be 0. Then only we can say that that is a principal plane, right? So, if you are considering a principal plane, the principal stress acts normal to the principal plane. Remember that. Many of us do not know what actually the principal stress and principal principal plane means. For that to explain, this time is not enough. Okay. So, I will take in later classes. So, if this, suppose this is your principal plane, then the principal stress acting in that plane will be normal. Either it is tensile or it is compressive. Remember, okay, the principal stress are always normal to the principal stress, principal plane. So, in a principal plane, the shear stress is 0 or must be 0. Such a plane is also, such a plane is set as principal plane. Not every plane will be having 0 shear stress. The plane which is getting the value of 0 shear stress, that is known as the principal plane. So, the answer is option C. There is no confusion in this question. So, the answer is option C. Let's move on to the next question. Okay, again a theory question. The bend moment is maximum on a section of a beam where the shear force is, shear force is. So, when you will get the maximum, when you get the maximum bending moment, or at what point you are getting the maximum bending moment? Okay, I think you all know the answer, right? So the point where your shear force changes its sign, the point where shear force changes its sign, 100% that point will be the point where you get the maximum bending moment. Okay, changes its sign means when you draw the shear force diagram, you will be getting a positive value, there will be a negative value. When you, the point where that value changes from positive to negative can be the point where the shear stress is 0 or the shear force is 0. Sorry, not shear stress, shear force is 0. Once you are getting a positive value of 5, you are getting a negative value of 3. The point where that positive value changes to the negative value, at that point the shear force will also be 0, right? So even though the shear force at that point is 0, the best answer will always be shear force changes its sign, because when we consider a simply supported beam, the shear force at both the points are in a way 0. That is not the point where the bending moment is maximum. So the best answer for the point where the maximum bending moment is always the shear force changes its sign. If you are not seeing that in your option, then you can check whether there is 0 in the option. Then you can go for 0. If both are there, the best answer will always be changes its sign. So where, or the point where the shear force changes its sign, that point will get your maximum bending moment. And the point where the bending moment changes its sign, what will you name that point? Can anyone say? The point where the bending moment changes its sign, that point is known as, when we draw the bending moment diagram, if there is a change in sign of the bending moment diagram, that point is known as, can anybody? Yeah, it is known as point of contraflexure. The point where the bending moment changes its sign, it is known as point of contraflexure. Okay, so here in this question, changes its sign is the answer. I am saying once again, the shear force changes its sign is the best answer, and if you are not seeing that in the option, then only you look for 0 value. If there is 0, you can go for that value. Okay, fine. Let's move on to the next question. Okay, this is a very good question. Okay, but you have to just think about the formula. What is changing? Again, it is deflection question. Deflection. Okay, how many? 5 or 6, right? So again, it is related to deflection. Again, it is a cantilever beam. Something is changing somewhere, and the corresponding value is they have asked, and this asked in percentage. So again, try to do without using calculator. Just write the formulas. The values get striken off. So just give us 20 seconds just for changing the battery. Okay. In the meantime, you can solve the problem. We will come after changing the battery. Okay, so welcome back. Just the question is in your screen. Just give that a try and solve it. Okay, so there is a cantilever beam with a rectangular cross section is subjected to a constant load at the free end. Okay, fine. If the depth and width of the another cantilever beam B is twice that of A and subjected to same load, the deflection at the free end B compared to A is. So the changing parameters are the depth and width, and they are getting doubled. Okay, so they are getting doubled. So think they are getting doubled. So how we can solve? These type of questions can ask for ISRO, or these type of questions are previous year questions, and the answer for this question is option A. Let's see how to solve. Okay, so you are having A and you are having B. So there is a point load at the free end, right? The situation is like that. Cantilever beam, rectangular cross section subject to a constant load at free end. So what is the deflection equation? So your deflection equation, general equation for deflection is delta is equal to W L cube divided by 3I. Or we can say all other remains constant, your delta is inversely proportional to 1 by I, right? I can even say that delta is a rectangular section, right? So it is 1 by I is BD cube by 2, so it is inversely proportional to B and inversely proportional to B and D cube, right? This is the concept. So for A, delta A is equal to 1 is proportional to delta is proportional to 1 by BA dA cube. Let it be like that. And here delta B is proportional to 1 by BB dB cube. Okay, let's divide both. So it is delta A divided by delta B. Okay, so it is BB into DB cube divided by BA into DA cube, right? Okay, fine. So we know that these are double, right? So 2 BA 2 cube is 8 DA cube divided by BA dA cube. You can strike off these values, so you get delta A by delta B is equal to 1 by 16, is equal to 16, is equal to 16. So what they have asked in the question, what is the deflection at B to A, right? So they have asked deflection at B to that of A. So we have found out A to B. So what will be B to A? Delta B by delta A is equal to 1 by 16, right? But they have asked in percentage. So what you have to do? You have to do nothing, just multiply by 100. So it is 1 by 16 into 100. So 1 by 16 into 100, you can easily calculate that, right? So 1 by 16 into 100, you are getting the answer as option A. So understand, deflection is very important. The questions they can ask, the ratios, the formulas, one get double, one get half, one comparing one to another. So these are the type of question they have asked over the course of all the time. Okay, so delta A given, delta B given, you take the ratios, you take the find the answer, you have asked in percentage, you have to multiply by 100 and you get an answer as option A. It is 6.25. Okay, let's move on to the next question. We are getting short of time. So this is an easy question, just solve it very quickly. So a steel bar is heated from 10 degrees Celsius to 20 degrees Celsius. This is a steel bar, not a composite or anything like that. It is simply a steel bar that is heated from 10 to 25 and it is free to expand. So the bar will induce Yes, yes, yes. The answer is B. Because in case of a single material, once you allow free expansion or contraction, so you are having a bar, you are heating it up and the temperature is increasing and the bar is expanding. If the free expansion is allowed, there is no temperature stress. If there is a contraction, which means you are decreasing the temperature, so it will get contracted. So if free contraction is allowed also, there is no temperature stress. Once the free expansion or contraction is prevented, then only you will get temperature stress for individual bars, not in the case of composite bars. Composite bar I have already explained the previous question. Okay. There is no requirement of any type of prevention. They can happen, but in case of individual bars, once the expansion or prevention is allowed, there will not be any kind of stress. So the answer is option B, no stress. Okay. Let's move on to the next question. 2019, similar question we have done earlier. So you understand the formula, just apply. You know the formula, I have already told the formula. Just apply, solve, find the answer without using calculator. Quick, very quick. Just write the formula. We already know, or I have already said. Apply the values. Again, the calculation step I have already said. Think like that and solve it. And try not to use calculator, okay? Because I have already said tomorrow exam we are not having any calculator. So whenever a root comes, we require some calculation purpose. The answer is option C. It is C. Okay. So again, I am not going to the main formula or the exact formula. Just I am writing the sigma x value is what? 400 and your shear is 150, right? 400. So it's 400 and your made by S shear is 100. Okay, fine. So your sigma x is 400 and your tau value is 150. So we can write the formula as sigma max is equal to sigma x by 2 plus root of sigma x by 2 the whole square plus tau xy square. Just substitute the values. 400 by 2 is 200 plus again 200 square plus 150 square. Similar value, right? Just one or two changes. So 200 taking 50 out, root of 4 square plus 3 square, it is 5. Then it is 200 plus 50 into 5, so that is equal to 450. Okay, so the answer is option C. Okay, so once you understand the formula, we can write it. So let's do one question from 2020. Okay. Do one. Okay, so we have done almost all years question. Just do one from 2020 also. Okay, can you solve this? Because it's getting late and you have to study other subjects also. So I am stopping with this question. The bulk modulus of elasticity of a material is twice its modulus of rigidity. What is the Poisson's ratio? Very simple question. It is asked in 2020, which means the last time the ISRO conduct the scientist exam. So the bulk modulus is twice that of the rigidity modulus. The Poisson's ratio is. Think about basic formulas. Just apply that basic formulas. You require two formulas. You have to equate two formulas. You can compare the formulas and find the answer. Okay. So let's see the answer. What is? The answer is option B. So here you require two formulas for this, which means the question is relating bulk modulus and rigidity modulus. Okay. So we know that E is equal to 2G 1 plus mu, and we also know that E is equal to 3K 1 minus 2 mu. Both sides are correct, right? So we can write like this: 2G 1 plus mu is equal to 3K 1 minus 2 mu, right? What they have said in the question, the bulk modulus is twice that of the modulus of rigidity. So 2G 1 plus mu is equal to 3 into 2G 1 minus 2 mu. Okay, fine. We can strike off GG 2 and 2, right? So 1 plus mu is equal to 3 minus 6 mu. Get this side, so it is 7 mu is equal to 2. Your mu is 2 divided by 7. Okay, fine. So the answer is option B. So with this we come to the last question. So hope you have all understand the concept and the formulas and the questions. Try to solve the questions by using or by not using calculator, because calculators are not allowed. So when you are revising the chapters or the subjects, then there are problem will come. So you try to solve without using calculators and you will be able to solve it. Okay. So with this we come to the end of ISRO marathon. Hope all these sections are useful to you and you will be able to score good marks. All the best. Thank you and good night.